Hi everybody, good afternoon. We are Edgar, Aldo, and Gerardo. We are from Tecla Monterrey, Morelia campus, and we're going to present our project for mission to Mars. The context. What is important? We know that in Mars we have an extreme environment, and this factor can be important when you're planning a mission to Mars. We know that in Mars we have a 388 gravity of Earth. Extreme change of temperature since minus 225.4 Fahrenheit in the night to 95.4 Fahrenheit in the day. We have strong blizzards in the planet. These blizzards can rise to 140 kilometers per hour. It has a very weak atmosphere. It only has a 1% like in Earth. And also has absence of magnifier, and what it means that this, with absence of magnifier, we have cosmic radiation that can reach the surface of Mars.
Okay, so this is the context, and if we are planning like our only robot mission, there's not a significant problem. But with humans, there are some aspects that we need to take care of, like these points are related to pressure, temperature, oxygen, food, the exercise that they need to do there, the radiation, the water, and the waste. So these points goes with some solutions or some other important points that we need to take care. That we need a habitable model completely pressurized, and to pressurize we need a giant amount of energy. We need to somewhere or something to store this energy and don't waste the energy and reuse it. Also, the greenhouse must have a stable temperature and must have a material to protect from radiation.
Okay, so talking about greenhouse, what we know they must have. They must have a regular temperature, they must have a regular pressure. The plants need solar rays, but if cosmic rays hit them, then the plants will die. So here we have.
Of all of these points, we focus, on greenhouse and energy. So with the greenhouse,
So here is our idea. That is a dome, and those that are inside are two greenhouses. The CO2 represents the carbon dioxide that the plants need to grow, and those two represent the oxygen that the plants releases. That is, that's a formula that says is the second law of Gay-Lussac, that says that the pressure is directly proportional to the temperature with a constant volume. It means that if the pressure goes up, then the temperature goes up. If the pressure goes down, then the temperature goes down. So, with a compressor, we can modify the carbon dioxide that the dome has. So we can control the temperature, and with a bulb, if the temperature goes up, then more up than we want it, then with a bulb, we can stop that temperature and leave it where we want it.
So why is this sun? In Mars, we need to talk about an isolated system, where the main point is that there is some protection, and there, when you can breathe, and there's the atmosphere and the pressure that the humans need. So also the plants need. The plants are very vulnerable to here on Earth, the temperatures of the greenhouses are regulated with windows and windows and water. But as you know, in Mars we can't open the windows because it's completely pressurized. And in this way, we have a constant and maybe more than one atmosphere in this space, so we can regulate by putting on air, that is carbon dioxide, and with an extractor and catching the oxygen that is raised by the plants. So with a high level of pressure, we can have high level of temperature, because in Mars we have low temperature. So with this we can have a completely stable environment, and we will regulate the inside greenhouses by changing its pressure, so the temperature goes up and goes down.
Now you're asking why we have two greenhouses in one dome. Why don't we have only one greenhouse? Well, this is in the draw we can see that in this greenhouse we want to grow gramíneas. In the basic plants for human food is our two types of plants. The gramíneas are the legumes. In this grow in one greenhouse we have to grow gramíneas like corn or rice, and in the other one we have legumes like beans or now why don't we have one? Because if we only have one greenhouse, one plant can be infected by a disease or maybe a plant. We have these provide food, meanwhile we repair this. And what is the dome made of? Well, we are thinking about the made of is of polycarbonate, like my glasses is made of, because we know that the polycarbonate absorb the light that the plants need and repels the light that can kill the plants.
The cosmic rays.
Also, an important point here is sorry, I don't know how to say it, pollinizers, the pollinization of the plants. It's an important fact in all the greenhouses, and it's a lot of work. Here in Earth are greenhouses that are pollinized by human work with little instruments, and it's a lot of work that can do the astronauts. So with this design, we can use only wind to this polymer.
Okay, so here's the benefits that we already said. With a dome, we are protecting from cosmic rays, but the light of the sun can pass. That is the light that they need to grow. With two greenhouses, we prevent plagues. Only two greenhouses, but more domes. Far from one another, and with this we mean that, for example, if something crashes in one dome, okay, then that plants are going to die, but we still having more domes. For the temperature, we apply the second law of Joule-Sachs. With more pressure of CO2 that fills up the greenhouse with a constant volume, the temperature increases and can be controlled by a valve. If the temperature decreases, we can control it by a compressor. Now, you may say that we need a lot of energy to make a compressor work. We think about batteries, but we have a lot of problems with them because batteries are too heavy to carry from the earth. 1 kilogram to space costs more than $1.3 million. The batteries are vulnerable to temperature and can easily be discharged, then they won't be useful. And the batteries have low efficiency. So we think in another ways of producing or keeping energy.
Yeah, we want to propose other ways to retain energy. There we have two, and they are mechanical. One, use the potential power, the potential energy of the gravity, and the other the pressure. The one of the pressure, we think about a tank. When you have a compressor and it carries a huge amount of gas with high pressure, and you have it underground because obviously the gas is changed with temperature. So you have it underground, and you have it a lot of potential energy retained there. And if you need electrical energy, you get out with a small hole, and it works. It makes work a turbine. The
other system for mechanic is using gravity. Why? How? Using gravity like a system of pulleys. This system of pulleys is simple. We have a base with rocks that we have already in Mars. We put rocks, and with a little pulley, we have to rise up the rocks moving by a big pulley that this will be our battery to retain the potential energy of the rocks. When they reach the highest, we're going to release, and this potential energy will transform into kinetic energy. When this happens, our little pulley is going to spin, and with this energy of the spin of the small pulley, we can use by using a transformer to make energy.
Okay, so the battery, it's okay. Let's pass to generator. We have the same system of pulley as a generator.
As a generator, yes. In this is the example that I have explained. You have rocks. These are a small pulley. The astronauts, I made the astronauts inside of the habitable model because it's more work, and it's more difficult to an astronaut get out of the model, and with the space we can do this job. What I propose, you can do inside of this model, you can also do exercise that they need to prevent the muscle loss, because we know that the gravity on Mars is 3.8, and this can help to the muscles, to loss of muscles. This is, we use this small pulley, the rocks rise up. When it's in the high stuff, you release, it's converted in kinetic energy. This small pulley is gonna spin, and with this spin, we can also use a generator that can produce energy.
Okay, and we have another type of generator.